So this is just a little bit of a reminder from last class. Remember, type 1 errors, those are the ones that are sort of unavoidable. Well, they're both unavoidable. So type 1 error is when you reject the null hypothesis when you should not. So in other words, it's when you get an unusual sample. So remember, 95% of the time, you're going to get a usual sample. 5% of the time, you're going to randomly get something unusual. If you think back to when everybody flipped a coin 100 times, right, and like roughly 5% of the class is going to get, they don't realize that they're going to get an unusual sample and say, oh, I found something, they're going to write a paper, and then people can't reproduce it. That's a type 1 error. Type 2 error, I'm just going to show you what some other people said. Type 2 error is when you do not reject H naught and you really should. So some of the things that people have said before in class that were really good ones were type 1 error is sort of when you kind of get lucky, right? So you think that you have something unusual, but really it's just an unusual sample. And that's when you reject H naught when it really is not unusual. Type 2 error is when your mean is different, but not different enough to register as being unusual. It's kind of out there, but it's not far enough away to kind of say, oh, for sure it's different. All right. We also discussed the critical region last class. So remember this part over here, non-critical region, not shaded, not unusual. It's close enough to where you expect it to be. Right? The null hypothesis says you are right here. If the null hypothesis says I'm right here and I'm in this region, I'm like, well, that could be true. I'm close enough to be reasonable. If I'm way out here, then I don't think the null hypothesis is true, so I'm going to reject the null hypothesis. This is the rejection region. What separates the two regions is the critical value. That's the z-score that separates the two. If your z-score is beyond that, then you're unusual. So that's why you find the test stat. If your test stat, your sample z-score is beyond that, unusual. Why am I reading? I'm tired of reading. Drew, go ahead and read for me.
The critical value CV is the z-value that separates the critical region from the non-critical region. It is based entirely on alpha. Just as it was in chapter 7, you find the CV by doing...
That's okay. That's good from there. Thank you. Right. You can either do this whole inverse norm thing, right? But that gets really confusing because then you're like, when do I divide by 2? Do I divide by 2? All that other stuff. So instead, we're just going to use a t-table with degrees of freedom equal to infinity. We're going to skip all that confusing divide by garbage and just use a t-table with degrees of freedom infinity because these are our z-scores. Okay, so far? All right. So, left tail test. I want people to read this part, then that part. Let's start with Austin. Go ahead.
All A in the left tail.
Alpha.
All alpha in the left tail. Contractor wishes to lower bills less than below degrees.
And then this part over here.
H naught equals
U naught.
U naught. H1 E is
U.
U is less than U naught.
Great. I would say U naught.
You know.
See, it's not hard to say. You have to go through it. All right. U naught. Okay. So how do you know it's left-tailed? So that's going to come later. People are like, how do I know what tail is? How do you know it's left-tailed? And how words like lower, less than, decrease, below, those are all left-tailed words. If you see that in your claim, that's indication that it's a left-tailed problem. How about Alberto? Oh wait, I read to make you last one tonight. Diego, go ahead and read for me.
All alpha in the right tail and additive to degrees of life more than, greater than, H naught, U equals U naught, H1 U greater than U not.
U not, yeah. Good. Right, so right tail tests are where your claim is things like increase, more than, greater than, right? Right tail. So those are the verbal cues in your problem that you have a right tail test. Two-tailed. Lindsay, go ahead.
Two-tailed test. Alpha is divided equally between the two tails of the critical region. Will the pulse rate increase, decrease, or remain unchanged? Is equals and differs. And then H naught, mu equals mu naught, and H1 mu is not equal to mu naught.
Great. So, actually, I should have changed this. I should have pulled out this part. That gets confusing. But these are the words that indicate two-tailed. Remain unchanged, or differs, is, equals, changes, right? Anything that, so two-tailed tests are where it's either like something is, something equals, or something is not equal, something changes or differs. Either one of those will give you a two-tailed test. Because if your claim is, then your alternative will be the opposite. If your claim is not equal to, then your claim is also going to be two-tailed, not equal to. So those are your cues that you're dealing with a two-tailed test. Is or are, equals, differs, that sort of stuff. All right. Please note the critical or unusual regions and the non-critical regions are separated by a z-score or a t-score called critical values. We find those from our tables, right? Same ones from chapter 7. They're not at all different. All right. So for a z distribution, when do we use z distributions again?
Right now.
Mean Mr. T, so means T. When do we use the z distribution? Easy peasy. PZ, proportion, z table. So we're going to use a z distribution when we have proportions. Option 1, the one I want you to use is look it up in the t table using the correct number of tails and degrees of freedom of infinity. Remember the very last row, degrees of freedom is infinity. That's your z-scores. That's your little z table. Option 2, if you have a TI-84, you can do the more complicated version, but I'm not even going to go there because there's no reason for you to do that. Find the critical value for a t distribution. When do you use a t distribution? Mean, Mr. T. So whenever you have a mean, you're going to use a t distribution. So here, look it up on your t table. So here's the deal with our t table. If you look at your table, pull out your t table, take a look at it, and you'll see the top row. I think everybody has it. Good. The top row says confidence interval. That's for chapter 7. The next row down, the middle row, says alpha level two-tailed. If you have a two-tailed test, you're going to use that row to figure out which column to use. The third row down says alpha level one-tailed test. If you have a left or right-tailed test, that's the row you're going to use to determine which column to use. Good? And then degrees of freedom is n minus 1. Don't forget that. N minus the number of variables. So we have one variable, x, n minus 1 degrees of freedom. So that tells you which row to pick.
Wait, what do we use for level two-tailed test again? For alpha level two-tailed?
Two-tailed test?
Yeah.
The middle, the one that says alpha level two-tailed test.
Yeah, which, you said for the alpha level one-tailed test, you said left or right, and then for this one, do we just do...
Whenever it's two-tailed, you use the two-tailed test.
Ah.
Whenever it's left or right, you use the one-tailed test.
Yeah.
So for example, if I have a two-tailed test with an alpha of 0.05, I'm going to use the third column. And then the row I'm going to use is going to depend upon my degrees of freedom. You can also use the TI-84 calculator, but again, I don't recommend that. We're not going to go there. All right, so let's look at these together. Find the critical value for a proportion where alpha is 0.01 and it's a two-tailed test. All right, so it should end at 2.58, we'll see. So a proportion is going to be what, Z or T?
Z.
Z, okay, and it said it was alpha is 0.01 and it's a two-tailed test. So two-tailed test, so it means I'm using this middle group here. Alpha is 0.01, that's this one right here, which means I'm going to use this column. And the z-score is the one at the very bottom. Everybody on board? So my z-score will be, well, okay, so then comes the question of a two-tailed test. It's going to be a positive one and a negative one. 2.58 or 2.575, I don't care which one you use, either one. I think for the homework you might need to round it to 2 decimal places, I believe. But again, two-tailed, you're going to have a positive one and a negative one, because it's two-tailed. The negative one will be on the left, positive one will be on the right. Okay, next example. One-tailed proportion. So again, it's going to be a z table. One-tailed test, alpha 0.01. So left-tailed is going to be over here on the left side, which means it needs to be negative. One-tailed 0.01. So let's see, one-tailed, that's going to be this section here. 0.01 was it? Yeah. So 0.01 is right there. And it's going to be a z distribution, so all the way down to the very bottom. All right, so you might think it might be 2.33, but really it's negative 2.33 because it's left-tailed. Right, so it should be on the left side. All z-scores on the left are going to be negative. All z-scores on the right, because they're above the mean, are going to be positive. Okay, right tail. Let's see, this is, again, a proportion. Alpha 0.01. So that's going to be one-tailed. One-tailed 0.01. Did I do that right? Yeah. So here, when I go down, boom, right there, only difference is this one's going to be positive 2.33, not negative, because it's greater than, it's a right tail. Right tail is going to be on the right, so all the z-scores will be positive on the right, all the z-scores are negative on the left. All right. Okay. I think we can skip. Oh no, we're not. I want you folks to do these ones. So find these 3 z-scores. So there's z-scores. So if there's z-scores, they're going to be the bottom row for proportions. Using your t-table. Let's take 60 seconds and find them. Okay. So the first one, Angela, what did you get for the first one? 1.645. Okay, so that's almost correct. Remember, it's left-tailed, so it needs to be what? Negative. So if folks have trouble, it's alpha 0.05. So that's one-tailed. 0.05 right here. 1.645. The next one, Kayla, what did you get for the next one? 1.960. Yep, 1.960. But what's up? It's two-tailed, so it should be what? Plus or minus. Yep, plus or minus. Both those. Everybody on board? And again, if you look back at our thing here, it's two-tailed, 0.05, all the way down. That one right there. And then the last one, let's see, 0.005 right-tailed. Lindsay, what'd you get?
2.576.
Positive or negative?
Yeah.
Positive.
2.576. And again, one-tailed, right here, all the way down. And because it's right-tailed, it should be positive. Good? All right. Great. So now you have all the pieces you need. Now we're going to look at the steps for hypothesis tests. Let's get someone to read these. Who's a good reader? Any volunteers? Okay. Oh, yeah. Go, Ryan, go ahead.
Hypothesis test comparing Z to T-scores. Step 1, state the hypotheses and identify the claim. Step 2, find the critical value and draw a picture. Step 3, find the test stat. And step 4, make the decision, reject/not reject each knot. And step 5, summarize the results for the claim.
Good. All right, so those are the 5 steps. You should be writing them down in your notes. Please note, step 4 is all about H naught, rejecting or not rejecting. It has nothing to do with your claim. Step 5 has nothing to do with H naught. It's all about your claim. So if you're watching at home, pause until you finish writing this down.